This is the problem to determine the center of mass between Earth and the Moon. And the problem reads, the Earth and the Moon are separated by a center-to-center distance of 385,000 kilometers. The mass of the Earth is 5.98 times 10 to the 24 kilograms, and that of the Moon is 7.35 times 10 to the 22 kilograms. How far does the center of mass lie from the center of the Earth? Okay, so first of all, of course, my my picture here, I put the Moon kind of to scale to the size of the Earth, so that's pretty accurate actually. But I can only put it this far out. It's actually 5 times further out. So the distances between the two are not to scale here. Okay, let's see how we're gonna attack this. Let's say that the center of mass is somewhere over here. I'm not saying that it is. Should be definitely a whole lot closer to the Earth than the Moon, because the Earth's mass is quite a bit larger, approximately 81 times larger. Okay, now what they give us in the problem is, of course, the mass of the Earth, and they give us the mass of the Moon. We're supposed to figure out is the center of mass, so this point here, wherever it is, and then they give us the distance between the two. They don't give us the individual distances, but here is the way it works. So this is what we're supposed to come up with somewhere as the center of mass, and we are free to choose the 0 point. So let's say I choose the 0 point here, and then this here would be the center of mass distance, and this here would be the distance to the Earth, and this would be the distance to the Moon. Now this one here is roughly 7,000 kilometers the way I drew it. However, we are allowed to choose this one arbitrarily, and we like to choose it in such a way that it's kind of convenient. So if we choose the 0 point here, then the distance to the Earth from this 0 point here is 0, and we know it. And from here to here is then the distance to the Moon, and we know that as well. Now, one more thing about the 0 point. In these kinds of problems, we are free to choose that 0 point. Still, the center of mass will be at the same point, because that doesn't change. That's independent of the 0 point. In the lab, I also chose it arbitrarily, but we always also like to choose it conveniently. So in the lab, I chose it as being the pivot point for all the horizontal rods in the mobile that you're building. So in this case here, I choose it, well, the center point of the Earth, and then we know how far it's out. Okay, the equation, of course, is going to be xcm equals, maybe I should try this a little bit different, make myself a nicer looking fraction bar. Okay, for some reason it came out gray, oh well. And then I have mass times x1, they're writing. Yep. So mass of the Earth times the distance of the Earth plus mass of the Moon times the distance of the Moon divided by the combined mass. Okay. And as I said, this one here would come out to 0, so it's basically going to be the mass of the Moon. Mass of the Moon, which is given as, I believe that was 7.35 times 10 to the, let's see, it was 22. Yep, 22 kilograms. This was times, was supposed to be a times 10 to the 22 kilograms times the distance from the Moon to the Earth, which is 3.85 times 10 to the 8th meters. Again, that's supposed to be a times 1 there, and then the combined mass, 5.98 10 to the 24, or 598 10 to the 22nd plus the 7.35 Here you can see that ratio of that the Earth's mass is about 81 times higher, so 10 to the 22nd. Because I changed the exponent on this number here, that's why I'm able to factor that out. And that is kilograms. And when we calculate that, we will come up with a result in meters. 4.67 times 10 to the 6 meters, or 4,670 kilometers, or a little bit less than 3,000 miles. And that means that the center of mass lies about 3/4 of the way towards the Earth's surface. And because when you check in the book, there is also the radius of the Earth listed as 6,380 kilometers, so yeah, 3/4 way out. Of course, it's not a fixed point because the Earth rotates and the Moon orbits around Earth, so any one point is kind of moving through the center of mass. And we can see this in this applet that you have used for the lab on orbital motion. Don't mind that my Earth is yellow and my Moon is pink. I wasn't able to change that, and I put in that the Earth is 81 times larger than the Moon's mass. And then I start this one here, and you can see that tiny wobble there, and of course the tiny wobble is caused by Newton's third law, that as the Earth attracts the Moon has to attract the Earth with the same force, and that causes an acceleration. The acceleration, that granted, is 80 times smaller, which is why you see that the Earth only wobbling around here rather than really orbiting, but it is really kind of wobbling around the common center of mass between the two.